All right. Today we're going to talk about probability simulations, guys. Does anybody know, for this probability situation, we're going to look at China's policy on childbirth. Okay. Does anybody know the rule that China has in terms of...
They can't have 1 or 2 kids.
Is it 2?
It's 1.
It's 1.
Okay. It just changed.
In China, they just changed it. Maybe they got my lesson from the first hour.
She's Chinese. You should ask her.
Okay. Is it the case? Is it 1 or 2? 2. 1 in the city. Okay. So in my book it says they have a rule of just about 1. Okay. All you could have was 1 child. Me tells us that if you live in the city you can only have 1. Okay. Okay. Me telling us that if you live in the city you can have 1. If you live out in the farms you can have as many as you want. Me. Probably.
Because they want boys.
Oh yeah, they want boys out there, don't they? All right. So, me agrees with what I got from the book was that people who live out in the country in China, they didn't like the idea of only having 1 child because what's the chance if you have 1 child that you get a girl? 50%, right? So what's the chance you get a boy? 50-50, right? Now people who live out in the country, they wanted boys, right, me?
Everybody wants boy.
Why do they want boys?
Because I don't know.
Because you don't know? Okay.
They work harder.
From the information I have, in the culture, especially out in the farmland, they wanted a male heir because when people got married, the husband and wife would move in with the husband's parents, and then would work the husband's parents' land and eventually take care of his parents. So if all you had was girls, would anybody work your farm?
No.
No. Would anybody take care of you?
No.
No. Okay. So that's why everybody wanted boys. Okay. So I guess my situation is a little outdated because me tells us now that in the city you can only have 1, in the rural you can have as many as you want. All right. But let's say we're back in the situation where we can only have 1. All right. Now that might not be very fair because some people want boys too. Travis, Erica. I'm not just talking for no reason up here, right? All right. So our policy that we're going to, let's go back to the 1 child. They want only 1 child because the population there was 1.5 billion. Okay, that's a lot of people, right? If each family is only allowed to have 1 child, what's going to happen to our population? It'll decrease, right? When everybody has their child, eventually it'll go up. But then as we work through from generation to generation, if 2 people only have 1 offspring, then 2 becomes 1, and what happens to our population? It goes down, right? It essentially gets halved, right? Okay. Well, the problem with that rule is that not everybody would get a male heir like they want. So let's say we're going to put a different rule in. We're going to propose another policy to the Chinese government, where instead of saying you can only have 1 child, we're going to say you are allowed to have as many children as you want until you have a boy. Once you have a boy, then you're done. Okay, does that sound like a pretty fair policy?
Yeah.
Yeah? So you can have as many children as you want until you have a boy. Once you have a boy, you're done. Okay, Alex, trying to work on your packet. If you need help, let me know. All right. What? So there's one problem. Erica says if we do it that way, there's going to be way more girls. Okay? Well, having that policy, does that change the probability? No, it doesn't change our probabilities, does it? So we still should have 50% boys, 50% girls. But we'll see if that works out, Erica. That's a good idea. All right? What do you have in our population if we let everybody have a child until they have a boy?
A lot of.
You think it's going to go really high, Jared?
Yeah.
Yeah? Who thinks it's going to increase? How many? Raise your hand.
It's going to increase that much.
Not that much, but it's going to increase? Who thinks stay the same? Who thinks stay the same? Okay. Who thinks decrease? Okay. Now, on average, who thinks we're going to have 1 child per family? Like they did with the old rule. Okay. Who thinks 2 children per family? Who thinks 3? Who thinks 4? 5? More than 5? Okay. And we already talked about this one, but who thinks there's going to be more boys than girls? Who thinks there's going to be more girls than boys? Okay. Now, to figure this out, there's 2 ways of going about this. We can say we can call up a whole bunch of people and say, hey, have babies until you have a boy, and we'll count how many you have of each. Okay? Is that a good idea?
Yes.
No. Okay. For one, it's going to take a really long time to start collecting data, like 9 months or so. Okay. For two, you probably should plan when you're going to have your children, not just do it for an experiment. Not a good idea. Okay. And for three, we're learning about probability simulations, so maybe we should use a probability simulation instead. Okay. And we only have an hour of class, which now is less than an hour, so we can't wait 9 months to get our data.
I think that's a good idea.
Okay. Might not be a good idea because you guys will all be juniors by then. Some of you will be with me still, but we'll wait till next year. All right. So instead of waiting 9 months to get our data, we're going to do what's called a probability simulation. All right. A probability simulation, right, it's kind of like any other simulation. Right? A probability simulation imitates the situation. Okay? Imitates the situation by creating outcomes with the same or similar probabilities to predict the outcomes of policies or real-world situations. Probability simulations are used when countries decide to make policies about numbers of children. Okay? Probability simulations can be used when we're talking about traffic flow. Okay? They can be used when we're talking about buying certain products. All right? Probability simulations are very useful. It's a very useful technique to seeing how or to predict outcomes in a given situation. All right? So we're going to use we're going to use a probability simulation to predict our outcome in this one. All right? Does that make sense, guys? Yeah? Okay. You're probably wondering, how do I make a probability situation or simulation? Well, the first step. Shh, Erica. The first step in a probability simulation is to understand our problem or situation. So, given our new policy, what's our problem and situation? I guess what's our situation? Everybody wants to have what type of baby? What type of baby? Everybody wants a boy, right? So our problem is everyone wants to have a boy, right? How are we going to solve that? What did I say our new policy was? That's the old policy. It was one child. That left some people upset.
Until you get a boy.
So our new policy is we're going to have as many children as we want until we get a boy. All right. Now, if you're copying down in blue, great. All right, that's going to stay up there the whole time. I'm not going to erase it, but I'm going to write examples of each step over here in black. All right. So these are kind of like our examples over here in black. All right. So the first one, understand our problem. Okay. So number one, everyone wants a boy. Right? So our solution then is we can have as many kids until we get a boy. Guys, please stop the side conversations. Okay, you might think this is a simple process or this is easy, all right? But you need to follow and pay attention so that way it stays that way. Because if you miss a part of this, then it gets confusing real quick. Okay? So everyone wants to have a boy. So our solution is we're going to have as many kids until we get a boy. Right? Now, step 2 of a probability simulation is to create a model. Okay? It's to create a model. When we create a model, we need to identify all of our outcomes. So for this model, how many outcomes are there? For having babies, how many outcomes are there?
53.
Infinite. No, just for having one baby. 2. There's 2 outcomes, right? Okay, we can have a boy or girl.
Or what?
Okay. That other one, chance, that's the possibility is so small, we're just going to eliminate it from our study. Okay? Because the probability of that is very, very tiny. Okay, it's like 1 over like 100,000 or something like that. All right, we're not going to do 100,000 trials. So, all right. So, probably 2 outcomes, boy or girl. What's the probability of a boy? Half, right? So 1/2 or 0.5, same thing. What's the probability of a girl? Okay. So we have our outcomes and the probabilities. Next step, decide if the probabilities will change with each trial. Now, does the probability with children, does it change after each birth?
No.
It does?
No.
So since my wife and I had a baby girl in August, does that mean our next child's gonna be a boy? No. It's gonna be another. How do we know that?
We don't know.
We don't know. It's the same probability. It's always 50-50, right?
Yeah. Let's figure it out.
The events are, what's that I word? What's the event? What's that, guys? Independent. So the first baby and the second baby are independent events. All right. So it's the probability won't change from each one. Now in some cases it will. For example, if I'm drawing cards from a deck, all right, and I keep the card out, what happens to my probability?
It goes down.
Does it change each time?
Yes.
Yeah. Because if I have 52 cards and I pull a card out and I keep it out of the deck, now I only have 51 in my deck. Right? So the probability of getting a certain card is out of 51 instead of 52. So that'd be a situation where the probability would change. Right? Next part of creating a model, we need to select a random device and describe how you can use it in the model. Now, a random device, I'm not saying randomly pick something to use. I'm saying select a random device. Select something that gives us random outcomes. Okay? What are some examples of devices that give us random outcomes? A coin. How many outcomes are there? 2. What else?
Dice.
A dice. How many outcomes? 6. And they're all random, right? Anything else? A spinner. Okay? With a spinner, the outcomes depend on the number of sections. Okay? Last one there is cards. 52 possible outcomes. Okay? So we need to pick a random device to use. And then we need to describe how we can use it in this model. So, what device are we going to use? Coin. Why a coin?
50-50 chance.
Okay, it's got a 50-50 chance, right? There's only two outcomes, right? So we're going to use a coin. So for this, we're going to flip a coin. Now I can't just say flip a coin, because if I say that, great, we're going to flip a coin. Well, what do the two outcomes mean? Okay, Dustin's saying we're going to have head being boy. So head equals boy, and tail equals girl. Would that work? Guys, would that work?
Yeah.
Yeah? Is there a 50-50 chance of heads and tails?
Yeah.
Yeah. Now, is a coin the only option I could use for my device in this one?
No.
Two-sided
No.
die.
Okay, a two-sided die is a coin. Okay?
It could just be a guy and even and odd.
Perfect. Marcel said we could use a die and just use even or odd. Right? Don't even and odds have 50-50 chance with one dice? Yeah. Is there anything else I could use?
Two-sided die.
Okay, so I have a spinner with 2 sections, right? That could work. Anything else? Can I use a deck of cards?
Yeah.
Cut them all in half? Okay. What are the 2 colors for deck of cards?
Red.
Red and black. Right? So as long as I replace the card each time I draw one out, a red card could mean boy and a black card could mean girl. Right? So a coin isn't the only option. It's probably the most practical one, but it's not the only choice. Right? Now, we're going to flip a coin. So that describes how we're going to use the device. Okay? The next thing we need to describe, though, is a trial. Okay? A trial, when we talk about that probability, it isn't a judge, jury, and prosecution and all that stuff. That's not the trial we're talking about. Okay? A trial is one full simulation. All right? Also called a run. All right? They're one full simulation. So it's like a test of our model. All right? Nice word. I like that. So besides picking our device, we also have to describe a trial. So what is a trial going to look like? What are we going to do? We're going to flip the coin once and call it good?
No. Several times.
Okay. Well, what are we trying to get?
Boy.
We're trying to get a boy, right? So if I flip the coin and I get a head, did I get a boy? Yeah. I'm all happy. Good. If I flip the coin and I get a tail, did I get a boy? No. So our new policy says we can keep having kids until what? Until we get a boy. So I'm going to flip my coin until what? Until we get a boy, until we get heads. Now, am I going to count the number of flips?
No.
Yeah, because each flip represents what?
A baby.
A baby. 1 flip means 1 baby, right? So if I want to see how this new policy affects the population, I need to count how many flips I do.
You got a coin?
Right? No, I didn't bring one. Did you guys bring one? That's okay. I'll show you how to use one on your calculator. We'll use it on your calculator. So, one trial.
There's a corner calculator.
Yes. There are corners on your calculator too. Okay. One trial is counting the flips
We got a corner.
until we get a head or boy. Put it in your folder. Yeah. Okay. So, guys, one trial is going to be counting the flips until we get a head. And the reason why we're counting our flips is because each flip equals one baby. All right. So if we want to see how this affects the population, then we need to keep track of how many babies are born. All right. Does this make sense, guys?
Yeah.
Okay. Now I know some of you guys are reaching for coins in your pockets. All right. We are not going to flip real coins because one, would spend most of our time chasing them. Okay. And two, the noise gets kind of annoying. Okay? So I'm going to teach you how to use a coin on your calculator. Okay. So use that one. Okay. So if you don't have your calculator right now, please go grab yours. Yes. Okay.
Dustin doesn't have one. I don't know how to use it.
Okay. Then go trade a different one. Okay. Here. Use this one. I'll use that. Okay. Now, on your calculator, the way you find your coin is you hit the button with purple writing. Okay, if you have one of my yellow calculators. If you don't have one of my yellow calculators, it's also the one that says APSS or APPS or apps. Okay. Hit the apps button. Yep. Not 4. Nope, that's context. Okay. Go to the one that has probability simulator, you guys.
Where's that?
Oh, that's 10.
Where's that?
Apps is right next to math. Okay. Yep. Go down to the one where it says probability simulate. Prob sim. There you go.
This too.
Frozen. You can hit it.
Wait.
Okay. So hit apps. Go down to where it says prob sim.
That's 0.
What? Yep.
Oh, I got 2.
Then go down to prob sim. It's the 10th choice. Right? And choose. Hold on a second, Eric. Guys, please don't get distracted by just flipping points because that's not all it yet. Okay, we'll get that in a second. Okay. So go to probability simulation. Your screen will turn black. It says press any key. Hit any key to go inside. All right. Then pick toss coin. It's the first option. Okay. Now to toss a coin, you can either hit enter. Okay. You can either enter or with the top buttons. If you look above the top buttons, there's different labels for them. You can hit one of those. Okay. Now, when we toss the coin in this, guys, the head, when we get heads, that means what? It means you get a boy. When you get tails, that means what? We got a girl. Now,
How do we know
One-
what I had to tell?
it says so. Toss the coin. Hit enter.
It's got like 6 heads.
Okay.
Oh, okay.
Okay.
I didn't know what to do.
All right. Now, one trial, guys. Okay. 1 second. Okay. One trial, guys, isn't one flip. It's one what?
Boy.
One boy, right? So one trial means you're going to flip until we get a boy. Okay, now, you guys all have this worksheets. Okay? Guys, hold on a sec. Please don't be flipping right now because I want to explain it to you because when people just start flipping, they don't do it right. Okay, what's the question, Jared? Okay, it's okay, but it's okay. Just sit right there. Okay, I'll help you in a second, okay? All right. Now, Sheila. Okay, when we're doing our probability simulation, okay, I have coin toss up. I'm going to hit enter, okay? It's going to flip a coin for me, all right? If that flips heads right away, that means it took how many flips? 1, okay? So if it only takes 1 flip to get a boy, I put a tally right here. Okay, that's 1 flip to get a boy. Okay. Now my next tally, where does it go? Does it go in the 2 box?
Yeah.
No. That means it took 2 flips to get a boy. Okay. My next time I flip, if I flip again and I get heads on my first flip again, that means I put another tick mark right there. Okay. Don't fill these in because this isn't your data, guys. All right. Now let's say I'm going along. Okay. I hit enter, it flips, I get tails. Is that a boy? No. That took me 1 flip. So now I hit enter again. I get a heads. How many flips did that take? 2, because my first one was tails and my second was head. So then I put a tick in the 2. Now, do I keep counting at 2 or do I start over? Start over. I flip again, I get tails. That's 1. Flip again, I get tails. That's 2. Flip again, I get heads. That's 3. So how many flips to get a boy? 3. So I put a tick mark here. Does that make sense, guys? Okay. Now, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 people in here, right? Now, we want to go through a large number of trials, because for number 3, it says conducted large number of runs or trials. This table says we want to do 200 trials. So if I have 22 people, how many trials should we all do? Okay, 10 will put us at 220, right? So maybe we should do 9?
I'll do 0.
Okay. Nope. I want everybody to do 9 trials. Okay. Now, once you get your 9 trials, I want you to come up here and put tally marks on here, and then we'll total them up. Okay. So get your 9 trials, Greg. Okay. Let's say 3 of them are 1s, so you'll come here and put your 3 tick marks in 1. Okay. And then as a class, we'll do the rest. Okay. Does that make sense, guys? Yeah. Okay. So get your trials right now.